All right, so in this lesson, we are going to solve for unknown. This should be unknown. Unknown angle. Oh, I'll do this. Unknown angle measures and lengths of parallelograms. So, before we do that, let's better define what a parallelogram is. So, parallelogram. These are all different parallelograms. Even this square would be a special parallelogram. But I mean, they're all related, right? These four-sided polygons. So first thing is, let's draw a parallelogram as best as we can. So in a parallelogram, we'll label this one A. I can do it a tiny bit better. Like this, and this. I don't know if that's better, but whatever. Parallelogram A, B, C, D. The first thing you need to know is that a parallelogram means that you have two pairs of parallel lines. So, two pairs of parallel lines. So, AB, I guess I'll find room over here. AB is parallel to DC, and AD is parallel to BC. Cool. Now, we also know that we have two sets of congruent angles. Angle A and angle C are congruent, and angle B and angle D are congruent, and angle B and angle D are congruent. So we're good so far. Now, what other color? I can use this one. So if I have a diagonal between A and C, and I have a diagonal between B and D, I'm going to put this as P. So AP is congruent to PC. AP is congruent to PC. AP is congruent to PC, and BD is congruent to, BP is congruent to PD. So BP is congruent to PD. And of course, if they're congruent, that means when these intersect, they cut each other in half. BD and AC aren't the same length, but when they cut each other, they divide each other in half. And I forgot the easiest one, AB. Let's see, what color can we use? I guess I'll go this one. So AB is congruent to CD. So AB is congruent to CD. Or I should put DC, right? And BC is congruent to AD. I'll put it the other way since this one is. AD is congruent to BC. And lastly, there is a special relationship that's kind of a little more difficult to see, but let's try. So I'm going to draw this parallelogram on top of this one. I'm going to try to replicate it. So if you can tell, this angle and this angle are the same. This angle angle BAD is the same as this angle right here, which means this angle, well, this angle, how about this? This angle here and this angle here are supplementary. And if this one is the same as this one, that means angle A and angle B, or I'll put plus angle B, angle A and angle B are supplementary, so they add up to 180 degrees. And that means angle C and angle D plus angle D are also 180. And of course, it's quadrilateral, so all the angles, the angle sum is 360 degrees. So let's try to use some of this knowledge. All right, so find the values of G and H. So we know that this side length is equal to this side length. So I know that 7 equals 16 minus H. I'll write 16 a little cleaner. 16 minus H. So I'm going to write it this way. 16 minus H equals 7. Subtract 16. Negative H equals 7 minus 16 is negative 9. Divide by negative 1. And H equals positive 9. I'll write that H a little better and further away. H equals 9. There we go. I guess we put 9 units, right? And let's go ahead. I don't know what's going on with this. I mean, I know it's probably bad always, but certain times it bothers me more than others, you know what I mean? Okay, now we need to find the value of G. Well, we know that these two angles are the same, are congruent. So G plus 4 equals 65 degrees. So minus 4, G equals 61 degrees. Oops. G equals 61 degrees. Cool. So we're given this parallelogram, and we are given diagonals and some lengths. So LM, oh, sorry, I didn't put the little, I should put that. Okay, LM, well, QN is 13, and since they're congruent, LM is also 13 units. LP, so LP, oh, LP is here. Well, if LP, if we don't know what that is, but PN is 7, then LP is 7 also. LQ, we don't know, but it's the same length as MN, and MN is 8 units. Cool, not too bad, right? MQ, so segment MQ, side length MQ. Well, let's see. If this is 8.2 right here, then that means if these are the same, that means that's also 8.2 units. I don't know what's up with my 8s. Plus 8.2 is 16.4 units. I'll just show that that's the work. 16.4 units. So angle LMN. Angle, the measure of angle LMN. Okay, so let's do this. We want to know this angle right here. So we know that this, I guess it's saying this whole thing is 100. So that means this is 100 also. So we have 360 minus 200, because 100 and 100. I guess I could put it that way for y'all. Minus 100 minus 100 is 160 degrees. But that's for both of these. And we know that they're congruent, so we need to divide by 2. And we get 80 degrees. So that goes right there, 80 degrees. All right, so angle N, the measure of angle NQL. NQL. Oh, well, I already found LMN, so, and that's the same. So this is also 80 degrees. Ooh. And measure of M and Q, M and Q. Oh, we said that's the same, so that's 100 degrees. And lastly, measure of angle LMQ. LMQ. Okay, so LMQ. This cuts this diagonal right here and this diagonal right here. Are they? Let's make sure they cut it in half. Oh, so LMQ. Remember that if these are parallel, how do I say this? So these are parallel, like this. And if it's cut by a transversal, that this angle is the same as this angle. This angle right here is congruent to this angle right here. So, oh, hold on, let me draw that in a different color, because I think I draw that wrong anyways. So we're looking for this angle right here, cut by this one, or created by this one, this transversal cutting through this. I think this is right. I guess I'll try it again. And this cuts here and here. Okay, so this is making me think that it's the other lines actually right here. So these parallel lines are cut by this is the right one. This one right here. So this angle is congruent to this angle through alternate interior angles. So that's 29 degrees. And it looks like that's it. Thank you.